Good morning, all of you. Today I will start law of conservation of energy to prove it and power. Law of conservation of energy states that energy can neither be created nor can be destroyed. Only one form of energy can be transformed into another. In class 9, you are supposed to state and prove it. So statement is energy can neither be created nor it can be destroyed. It can be one form of energy can be converted into another form. Now it's proof. So for proving it, consider a body of mass m. Let it be at a height h from the ground. So at the highest point, what will be its initial velocity? It is 0. Let it fall from the height a. We indicate the height of the object as the position we locate it as A. Let the stone or the body is at position A, which is at the height h from the ground. Let it fall from the position A and it reach, after moving through a distance x, it reached to the position B. Let the velocity at position B is v1. And then it fall to the position C. Let v2 is the velocity with which it fall at position C on the ground. Right? Now potential energy at position A. We will start with A. What is the potential energy of the body at position A? It is mgh. M is mass of the body, g is acceleration due to gravity, and h is the height. Now what is the kinetic energy of the body at position A? It is equals to half mv square. Since the velocity at A is 0, as the body is at height h and it fall from the height h, so the velocity at A will be 0, so total kinetic energy will be 0. When you substitute in place of V 0, you will get the whole term become 0. So total energy at position A is equal to sum of potential and kinetic energy. This is equals to potential energy is mgh, kinetic energy is 0. So mgh plus 0 will be equals to mgh. Let it be equation number 1. Now come to position B. At position B, what is the height? Total height is x. The body fall through a distance x. So the distance between B and the ground is h minus x. So potential energy at position B will be mg h minus x. Potential energy at B equals to mg h minus x. Now this is equal to mgh minus mgx. Now for finding out the kinetic energy at B, use third equation of motion to find the value of v1. v1 square, that is final velocity at B. v1 square minus u square. U is the velocity at position A. This is equal to 2g as the body fall through a distance x. So it will be 2g in place of h, you are going to write x. Since u is 0, so v1 square will be equal to 2gx. Therefore, kinetic energy equals to half m v1 square. This is equals to half m. In place of v1 square, you are going to write 2gx. 2 will get cancelled. You are getting mgx. Therefore, total energy at B, this is equal to potential energy plus kinetic energy. Potential energy here is mgh minus mgx and kinetic energy is mgx. So mgx, this is minus mgx, this is plus mgx, it will get cancelled, and what is left? Mgh. Now come to position C. At position C, the final velocity, the velocity is v2. And what is the height at C? It is 0. So potential energy at position C will be 0, as H equals to 0 here. Potential energy equals to mgh. H is 0, so total will become 0. To find out the value of V2, use third equation of motion. So V2 square minus U square equals to 2gh, since the body fall through a distance of h. Now U is 0, so we are getting V2 square equals to 2gh. Since U is 0, now kinetic energy at C is equal to half m V2 square. Make it V2 square. This is equals to half m. In place of V2 square, you can write 2gh. 2 will get cancelled. This is equal to mgh. Now total energy is equal to potential plus kinetic energy. Potential energy is 0. Kinetic energy is mgh. So total energy will be mgh. From first, second and third, 3 equations we are getting. So from first, second and third, we can conclude that the total energy of the body remained conserved. That is, it remained constant and it is coming mgh. I think it is clear to you. Now next you have to read about power. What is power? Rate of doing work is known as power. The rate with which work is being done, we call it as power. Power equals to work by time. Work, we know it is equals to force into displacement divided by time t. We can shift this t below s also. So you are getting F into s by t. But s is distance and t is time. S by t is velocity. S is here displacement by t. So we can write V. So power equals to F into V. You are getting two formula in hand. Power equals to work by time. Power equals to force into displacement by time. Power equals to force into velocity. SI unit of power is watt. How will you define 1 watt? When 1 joule of work is done in 1 second, power is said to be 1 watt. Bigger unit of power is kilowatt. 1 kilowatt equals to 1000 watt. Other unit is horsepower. 1 horsepower equals to 746 watt. Power is said to be 1 watt when 1 joule of work is done in 1 second. Now next, establish relationship between kilowatt hour and joule. What is kilowatt hour? This is the commercial unit of amount of electricity consumed. In which unit you will get the amount of electricity consumed in your home? It is in kilowatt hour. Now one question can be asked in 1 marks question, that what is the difference between kilowatt and kilowatt hour? Kilowatt is bigger unit of power, whereas kilowatt hour is the commercial unit of electrical energy consumed. Now, if you want to find out relation between kilowatt hour and joule, we will start with 1 kilowatt hour equals to 1000 watt hour. But 1 watt can be written as 1 joule by 1 second, and in 1 hour, 3600 second is there. Second will get cancelled. You are getting 36 into 10 to the power 5 joule. In scientific notation, we can write 1 kilowatt equals to 3.6 into 10 to the power 6 joule. This is the relation between 1 kilowatt hour and joule. 10 to the power 6 means mega. So in place of this, you can write 3.6 megajoule. I think it is clear to you. Now energy transformation. Energy transformation, just now you have read, energy can neither be created nor can be destroyed, but one form of energy can be transformed into other. So you have to identify what type of transformation takes place in different place. For example, if you are asked, write down the energy transformation in thermal power plant. So in thermal power plant, we are using coal. What type of energy coal is having? It is chemical energy. When you burn it, heat is produced. So chemical energy get changed into heat energy. That heat is utilized to convert water into steam. The steam is also having heat energy. Now that steam is used to rotate the turbine. So heat energy of the steam get changed into mechanical energy. As turbine is uh, connected with the coil of the generator, with the help of that we are getting electricity. So mechanical energy get converted into electrical energy. In 4 steps, the energy transformation takes place in thermal power plant. You have to write all the steps, that is chemical energy get changed into heat energy, heat into mechanical, and then mechanical into electrical. Now second one, in case of simple pendulum, when it complete one oscillation, what type of energy transformation takes place in case of simple pendulum? When it complete one oscillation. When the simple pendulum is in mean position, it is having only kinetic energy. When it moves to the extreme position, in between mean position and extreme position, the energy change into mechanical energy. It has both type of energy, kinetic as well as potential. When it reaches to the extreme position, it is having only potential energy. When it comes to the mean position again kinetic, and then when it goes to another extreme position on the other side, again potential, and then it comes back to the mean position, it has kinetic energy. So you can start with, in the mean position it is kinetic, in the extreme position it is potential, again to the mean position kinetic, again to the other extreme position potential, and then it come to the mean position, it is kinetic. Now one oscillation is over. Now, what type of energy transformation takes place when a stone rolls down from the peak of the mountain? At the peak of the mountain, what type of energy it is having? Only potential. When it rolls down on the way, it has mechanical energy, and on the ground, when it reached on the ground, it has kinetic energy. After then, what happened? You will find that the stone will rolls down, and the kinetic energy, a part of the energy get changed into heat energy, sound is also produced, and a part of energy gets stored as potential energy of configuration of the body and the ground. Thank you. Have a nice day.